So in this video, we are looking at the process of completing the square. And we're going to do this for both monic quadratic equations and non-monic quadratic equations. So what I'm going to do for these first ones, just to revise this, when I complete the square, I want to take the coefficient of x, I want to halve it, and then square that. So before we do anything, let's just look at how we do these first steps. So this left-hand side stays the same. I have x squared minus 4x plus, I'm going to halve that, minus 4 on 2 squared. And then because I've just pulled something new out, I have to undo that again. So I'm going to minus negative 4 on 2 squared. And then minus 5. Because I'm trying to make something that's equivalent to this, but just written in a different way. Now, what I get in the second line, after I've simplified this, is I get one part which is a perfect square and one part which is just a constant. So in my first one, I'm going to get x squared. I'm just going to put a bracket around it to really draw your attention to the perfect square part. So minus 4 on 2 gives us negative 2, and then we square that, gives us positive 4. And then we have minus 4 minus 5. So this part here is our perfect square. Remember this process of completing the square, when we halve this coefficient of b and square it and add it to this, this will give us a perfect square. It'll always factorize down to a perfect square. So this will give me, this bit in the brackets will be x minus 2 squared. You can verify this using PSF if you'd like. And then minus 4 minus 5 gives us negative 9. Now this gives us the equation in what we call vertex form or turning point form. Now in the next video, we're going to look at how we can apply this particular form of quadratic to graphing the actual quadratic. But we're just practicing completing the square for now. So with this second example, we're going to do the same thing. So we have x squared plus x plus, we look at the coefficient of x, which is 1, and we're going to halve that and square it. And then we're going to undo that. So we're going to subtract it again. So we're going to subtract 1 over 2 squared. And then I'm going to add this 1 at the end. Now this is going to give me y equals x squared plus x plus 1 over 4. This part is my perfect square bit. And then I subtract the 1 over 4, I should say. And then plus 1. And this thing on the left will factorize down if we do our PSF. We want two numbers that multiply to give a quarter and add to give 1. This is going to be a half and a half. So we get x plus a half squared and then plus 3/4. So once again, we have it in that same form. We have the perfect square and then the constant on the other side, or added or subtracted at the end. Now for the next two examples, we are looking at completing the square, but for non-monic quadratic equations. So for this one, what we want to do, because completing the square works when this is monic. So before we do anything, we want to factor out 2 from this right-hand side. So what that's going to give me is y is going to stay the same here. I'm going to factor out 2, which leaves me with x squared minus 6x plus 8 over here. Now I'm just going to divide this 2 to the other side just temporarily. So I'm going to divide both sides by 2. This gives me y over 2. And then now I just have my monic quadratic on this side where I can complete the square. So doing this, I'm going to get y over 2 equals to x squared minus 6x. And now I'm going to skip a couple of steps because we should be kind of used to this by now. I'm halving the coefficient of x, so minus 6 over 2 gives us negative 3, and I'm squaring it, which gives us positive 9. And that's my perfect square portion. And remember, I can't just add positive 9 out of nowhere. I have to subtract it so that I get an equivalent equation. And then I have my plus 8 on the end here. Now what I get is y over 2. And with this one, I want two numbers that multiply to give positive 9 and add to give negative 6. Those are going to be minus 3 and minus 3. So this will factorize down to x minus 3 squared minus 1 And then now I can just get this 2 back onto this side. So I'm going to multiply this entire expression by that. So 2 will get multiplied to this term and to this term over here. So multiplying the 2, I get y equals to 2 outside of x minus 3 squared minus 2. Alternatively, if you want, you can just leave the 2 here and just work with this bracket, and then you'll eventually get to the same thing. But this process is a bit easier because we just get the 2 over here for now, work with our monic really easily, and then we just multiply it back to both of those terms right at the very end. Now with this next one, we're going to do the same thing. So I'm going to get y equals to, I'm going to factor out the negative 1 here. So I have x squared minus 8x plus 15. And what I'm going to do is I'm going to divide by the negative 1 to get to the other side. So I get negative y equals to my positive coefficient of x squared, so that I can complete this square a lot easier. So I get minus y equals to x squared minus 8x, and I'm going to plus negative 8 over 2 all squared, which gives me 16. My perfect square portion, I need to balance this out by taking away 16, and then I add 15 over here. So what that gives me is this guy will simplify to x minus 4 all squared. And remember, if you've completed the square correctly, your thing here should always factorize down to a perfect square. That's why we're completing the square in the first place. So it can factorize down into a perfect square part. And then I get negative 1 here. And then now I just want to divide or multiply by negative 1 to get rid of the negative in front of the y, leaving it back in its form of y equals something on the right hand side. And that will give me negative x minus 4 squared plus 1, because this negative gets applied to both this term and this term over here, which changes the sign for both. But that brings us to the end of the video. Thank you so much for watching, and I'll see you next time.